All right, we're going to find the sine and cosine of 30 degrees. And you'll say, well, we already did that with special triangles. And you're right, but it's going to get us to some that we haven't had yet. But I'm going to build the method with one that we do know, going from the familiar to the unfamiliar. How's that? I'm going to pull out this red triangle again. It is a 30-degree triangle. From its coordinates, I know this side is square root of 3 over 2. And this coordinate, or this side, is, from this coordinate, I know the side is 1/2. And because we're on a unit circle, this side is 1. So I've lifted this piece up with the values of the sides of the triangle. So I want to know from here, what is the sine of 30? Sine of 30 is opposite over hypotenuse. It's always nice when your hypotenuse is 1, nothing to it. So we get 1/2 divided by 1 is 1/2. And the cosine of 30 is adjacent over hypotenuse. So we get square root of 3 over 2 over 1. So that reduces, simplifies to square root of 3 over 2. So notice the sine gave me 1/2 and the cosine gave me square root of 3 over 2. Look at this. Those two numbers appeared in the coordinate. And so that will always happen. This first coordinate is always the cosine of the angle. And this coordinate is always the sine of the angle. The way we like to remember that is the second one is the sine, because they both start with S. So the first one is your cosine and the second one is your sine. And that is always true all the way around the unit circle, both in 6th and in 4th. So I can point to this one, 7 pi over 6 is the radian measure of the angle that starts here and ends here. The sine of that is the second coordinate, negative 1/2. The cosine of that is the first coordinate, negative square root of 3 over 2. So any of the places on the unit circle can be done as well. So what about over here on the quarters? What is the sine of 5 pi over 4? The sine of 5 pi over 4 is the second coordinate, negative square root of 2 over 2. The cosine is the first coordinate, and it always works, no matter where you are on the unit circle. Let's conclude this by saying, where's tangent? All right, back to the drawing board. Back to this piece, let's see if we can find tangent. It turns out that the tangent of this triangle is opposite 1/2 divided by adjacent, square root of 3 over 2. So that simplifies by flipping the denominator and multiplying it by the numerator, and we get 1 over the square root of 3 when the 2's cancel. So we get 1 over the square root of 3, which rationalizes to square root of 3 over 3. So where is that on the unit circle? Is it there at all? Well, it turns out you can see that tangent was 1/2 in this 30 degrees. This is supposed to be 30 degrees. Tangent of 30 degrees is 1/2 divided by the square root of 3 over 2. And that's always going to be the second coordinate divided by the first. So that is true as well. Let's make a note of that, of all of it. Here's the key. Sine of theta is second coordinate. So this is on the unit circle. Second coordinate is sine. Cosine of theta is the first coordinate. And the tangent of theta is the second coordinate divided by the first coordinate. All right. This is a powerful thing in that it has added so many to our list. We started out doing sine, cosine, and tangent, only knowing sine, cosine, and tangent of 30, 60, and 45. Now, we know sine, cosine, and tangent for all of these spots around the circles, this one and this one. So we have added so many more to our list. All right, well, with that amazing lesson, look at that. You need to walk down to the lab and see it in person in all its glory if it's still here on Monday. All right, we will be using this over and over, and we'll be able to manipulate these values in our minds, believe it or not. So you can ask Calc, they know. So go ahead and bring all this glory to me on Monday and let me see it in your comp books. And in our problem set, you'll be seeing how we use it. So till then, you have a great weekend. Bye.